to DNA. No, let's move on to EEG. Yeah, so we're familiar with coherence. We record brain waves in a single person. We look at the electrical output of a single person. We see how different parts of the brain come together. And this is how we've been using to measure transcendental consciousness, cosmic consciousness. But there's a whole new understanding. It's called hyperscanning, or collective neuroscience. That is, measure EEG of many individuals in a social situation. This one had to do with teachers and students. And what they found is the students who did better on the tests, that is, they got the knowledge more readily, their brain was more coherent with the teacher. Other research looked at co-pilots and pilots. And they were it was simulated, but they simulated taking off, cruising, and landing. And what we're seeing here is each head is a different person. What is the coherence between their brains? And we see the more challenging the task, in each case, the coherence is highest. There's research on people cooperating or competing. And it's a simple task. You see an open circle. The circle starts to fill up with green, and that's the go signal. And for cooperation, you try to respond at the same time. The competition is you try to respond first. Single one, single two is one person is doing the task and the other person is watching. And what they find here is that this is the brain-to-brain synchrony. In the cooperation, the brain-to-brain synchrony is highest. So we're getting a measure of social interaction. Now, what is this? Well, some of it is just due to seeing the same task. If you take some people and they watch a movie on Monday, get some other people who come in on Tuesday, guess what? They have high brain-to-brain synchrony. And they align the brain waves up with the actual movie. So is this brain-to-brain synchrony, is it really something more than just being in the same situation, dealing with the same dynamics?